the notes.
Okay. Number 7. We've got 1 over sine squared A minus 1 over tangent squared A. Remember, we are simplifying these down to one number or one identity.
So
function.
Change tangent squared.
Change
Tangent squared.
tangent squared.
To tangent equals sine over cosine.
Oh, it's a sine squared over theta. Oh, sine squared A over cosine.
Okay, so I am going to go that direction. I'm going to do it a little bit, just in a little bit less steps. All right, I'm going to think about tangent squared A being 1 over tangent squared A being the same as cotangent. Okay, I think that. You know what? There are multiple different ways of doing all of these. But it gives you choices. So this one is going to be cotangent squared A. So if I change cotangent squared A, now what do you think maybe we should try? Okay, change that. So then I have 1 over sine squared A minus cosine squared A over sine squared A.
Distribute negative. Oh, keep it like that.
I don't know what you were asking me to. So now we have a fraction minus a fraction, and they have common denominators. So since they have common denominators, we can subtract over the same denominator 1 minus cosine squared A. And you have your identities handy, right? Oh wait, they're on the back of the page. So yeah, they're very handy, I hope. So you look at your identities and you say, hey, what is 1 minus cosine squared A?
Sine squared A. Oh.
1.
Miss Critical. I highlighted my way. This is
Did you get 1 for your answer?
I didn't write it because I was stuck.
You can try it a different way. There was a different way. Instead of changing cotangent to cosine over sine, you don't have to write down both ways, but I'd like to show you there was a different way. If you look at the original and you change 1 over tangent to cotangent, if you change 1 over to sine, which I don't usually recommend, but if you change 1 over sine squared to cosecant,
You want sines and cosines, maybe. That's what you said, yes.
if you change those to both the reciprocal functions, and then you go and you look at your identities, there is an identity that has cosecant and cotangent together. So if you go and you look at your identities, what is cosecant squared A minus cotangent squared A? It's 1. So I could do this same identity simplification in 2 steps instead of however many steps we just did it. So there are other ways. Sometimes you choose the easier way. Sometimes you give yourself more work, but
That's fine.
knowing which way to go comes from experience. So that's why you got to do work. You got to practice. Okay. So we've already done number 8, correct? We did number 8?
Yeah.
No.
But we stopped there and we haven't done 9, correct?
Yeah.
No.
So number 9. Let's look at this. We've got 1 over cosine squared theta minus 1 over cotangent squared theta.
Can you change 1 over cotangent squared theta into tangent?
Yeah. So 1 over cotangent squared theta is the same thing as tangent squared theta.
Tangent is sine over.
So we're leaving this one. We're just leaving that one. Is that what's going on? Okay. All right, so 1 over cosine squared theta minus sine squared theta over cosine squared theta. So we change everything to sines and cosines. What happens now?
Subtract the same denominator 1.
We have the same denominator, so we have 1 minus sine squared theta over cosine squared theta.
1.
Yeah. Remember with identities though, they're like doing proofs where you have to show every step. So you can't go from that to 1. You have to show from here, you have to show going to cosine squared theta over cosine squared theta. Then you can say that's 1. Did anybody try it a different way? Like you didn't go with me, you tried it differently, everybody? Okay, well, just so you know, one over cosine squared theta is secant, and one over cotangent is tangent, and that's from our identities. Just did one I was thinking somebody would say, no?
I knew it was the same one.
Okay. But it doesn't matter, if you take the long route and you get the answer, great. It's not matter, it's not a, it's not a,
Take the long route.
no, it's not a contest on who can do it the shortest, it's not a contest on who can give themselves the most steps, it's just get the right answer. And don't break any math rules. Brandon, what you got?
Equal cosine squared theta.
Huh? I don't know where you're pointing.
Cosine.
That's right here?
Yeah.
That's my
So
next step.
1 minus sine squared theta is
That
cosine
is
squared
different.
theta.
That's one of our identities.
Okay,
Come on, Brandon.
where's my $8?
Okay, next one is, we've got cosine theta multiplied by sine theta minus cosine theta. Any ideas?
I've had enough math for the day already.
Distribute? I'm gonna distribute. I'm gonna do something first. Before I distribute, what is secant?
1 over cosine over squared. No, 1 over cosine.
Cosine. So I'm gonna go ahead and I'm gonna change this to 1 over cosine theta first.
Minus cosine over 1.
Then I'm gonna distribute. So yes, it is over 1. So when I distribute here, I get cosine theta over cosine theta minus cosine squared theta, because you multiplied cosine times cosine. So when we multiply those, we get 1 minus cosine squared theta. Is 1 minus cosine squared theta an identity?
Probably.
Well, sine squared theta.
So far.
What?
Like,
Okay, next one.
oh my god.
Cosine squared A multiplied by secant squared A minus 1. Idea.
Change that secant. 1 over cosine.
Okay.
Oh, do
You can.
Actually, no, I want to change the cosine.
Is secant squared A minus 1
Already
an
did.
identity?
Think so. Yeah,
Yeah.
it's tangent squared.
Okay. So there are 2 different ways you could totally approach this one. We could either change secant squared theta or angle into 1 over cosine and distribute, or we can take this and make it tangent. I'm gonna go with, what did I do over here?
Tangent. Please do tangent.
Well, that's not what, I didn't do the tangent on my paper, but you could do it this way. I did the distributing with the 1 over cosine on my paper, but you can do it either way. There are different ways of doing these. Now from here, what should we do? Say what? Here. Okay, so we'll have cosine squared A, and then sine squared A over cosine squared A.
Take out the top. Oh, sorry, the top right. Hey, take out the top one,
Then you multiply it across, right?
We're gonna multiply straight across, so this is over 1, and when we are multiplying straight across, since we are multiplying, those cancel. Only since we're multiplying that those cancel. These are like little puzzles.
Yeah, it'd be so much.
They're problem
fun.
solving, and the more that you do problem solving, the smarter you become as an adult.
No. Who said I'm
So,
an
you know,
adult?
if you did some research, you'd find that that is true. Don't just say no because I said yeah. No, for real, when you problem solve, your brain is forming dendrites, which are the things that connect the neurotransmitters.
See, that's what you think. Science is otherwise.
Okay, that allow your brain to think faster. So when you're problem solving, you're making your brain think faster. And the more dendrites you have, the smarter you are. The more dendrites you have, the smarter you are. When you stop using them, your brain purges things. It plucks them out if you stop using them. That's why if you don't use it, you lose it. It's true. You should see me try to ride a bike. I don't have lots of, I don't have a bike, so.
Last year I went to Jungle Gyms and I tried doing like hula hooping and I couldn't do it enough. My mom was like, "Oh, that's so easy," and I'm like, "You try it." She did. It was pretty fun because she tried it 10 times and still couldn't do it.
Okay, guys, with number 12, can we take 1 minus cosine x and use our Pythagorean identity?
We could.
Oh, that's what we're talking about.
Science squared.
Okay, not science squared.
No, does that say 1 minus cosine squared?
Oh.
No, you silly
Not that we're-
goose.
okay, oh,
So you gotta be careful, because if it's not squared, it's not one of those Pythagorean identities.
I knew that.
Yeah.
So instead, I get it. Instead, since there's 3 things we're multiplying here, let's multiply 2 of them together and then multiply that answer by the third.
Yeah, the 1 minus cosine x and then the 1 plus.
You know what though? What is secant?
1 over
1 over cosine.
Yeah, change it.
So why don't we multiply this one by cosine
Oh,
x
that's
to
true.
start?
That's good.
And when we multiply it by cosine x, we have to distribute it because there's 2 terms. But when I distribute to the second term, something nice happens.
It becomes 1.
Right, the cosine x over the cosine x cancel out when I distribute to that second term. So I'm distributing cosine x times 1 and I get cosine x. I'm distributing cosine x times 1 over cosine x and I get 1. And I'm going to bring down my 1 minus cosine x from the beginning.
It's like a different squares.
It is, yeah. Now you can just reorder that and write it like this one. But I'll FOIL it just in case nobody saw that. So we'll FOIL now. So we'll do first is cosine x. My outer is plus 1, my inner is minus cosine squared x, and my last is minus cosine x. And then look carefully, do we like terms we could combine?
Yeah, cosine x. Into nothing.
So cosine x and minus cosine x make 0, and we get 1 minus cosine squared x. And what is 1 minus cosine squared x? There is no sin in math,
It's sine.
only sine.
I was right. I was the answer. I knew it.
But
Is this all we're doing today?
Yeah, we've had a lot going on. Yeah, just had a lot on our plate lately. Just fall asleep.
Oh, that's seen a kid fall asleep standing before. It was pretty
Oh, I've
funny.
seen that too. During a test.
Fall asleep.
I took away his desk during the test. Couldn't stay awake.
Yes.
I was serious. That was a long time ago.
Wait, let's change the bottom of this as well.
Change the bottom to what?
Sine squared.
1 minus cosine squared x. We just did it a bunch of times in a row. 1 minus cosine squared x is sine squared x. So now on top, we have sine x, cosine x. On the bottom, we have sine squared x. Now this next step would probably be in my head, but I want to show you so you understand what's in my head. You can't read my brain. So on top, we've got sine x, cosine x. On the bottom, we have sine x, sine x.
Oh, because it's squared. So
Because
two
it's
times.
squared.
Oh, so it's cosine.
And so, since the bottom I factored, we can cross out sine x.
It's cotangent. It's fine. Squares aren't too good.
Good. Work ahead then.
I can't do that.
Okay. So on the top and bottom, we canceled out sine x, and I'm looking and I have cosine x over sine x left, and that is cotangent. Okay. Next one, tangent squared theta. This one, I would be very impressed if somebody comes up with this with never seen an example before. Just saying. This one's a little bit tricky.
Well, just give me a minute.
What'd you get?
Wait,
Say
no.
-2.
Wait, Miss Criswell, before you do it, give us like 5 minutes.
No, we don't have that.
2 minutes.
Okay, so tangent squared theta over secant theta plus 1, and then that answer plus 1. So what I did
3.
is I did not change this. Did you change it all to sine and cosine? Okay, I did not change it to sine and cosine. You can, but I just want to show you a different way of doing it, okay? So what I did instead is I looked at my identities and I noticed that tangent squared theta in the Pythagorean identities has a secant in it. So if you look at your Pythagorean identities, what is the identity? Somebody read it to me that has the tangent and the secant in it.
1 plus tangent squared theta equals secant squared theta.
Okay, so on top I have tangent squared theta. So if I subtract 1, tangent squared theta is equal to secant squared theta minus 1. So what I'm going to do is I'm going to replace my top with secant squared theta minus 1, and then I have secant theta plus 1, and then that plus 1. Okay? Now I'm doing that because I know I can like foresee how this is going to go because I'm the teacher and I've done it a lot. I'm just showing you what you could do, and you'll see why in the next step. You'll see why I chose to do it this way. I cannot cancel secants right now.
Because 1's squared.
Well, it's not because it's squared and not squared. That's not why I can't. It's because of the plus or minus 1. You cancel those when they're next to a plus or a minus sign. Funny guys.
That's fine.
But we can factor the top. There's your candy. Well, we can factor the top, she does.
You can fake it.
Well, I'm not holding candy right now. So we can factor the top. That is a difference of squares. That is secant theta plus 1 and secant theta minus 1. On top, that is a difference of squares. Secant theta plus 1, secant theta minus 1. Difference of squares. Once it is factored, then you can cancel factors. So I get secant theta minus 1 plus 1. Answer is, yes.
What was that?
I don't know.
It's just secant theta.
Answer is secant theta. So if you get really stuck, maybe there's something that involves factoring. We are still doing factoring.
Speed this up.
Told you we do it the whole year. Still doing it. All right, last example.
Hey,
Hey, I think I got it.
So this one, is this an identity, a Pythagorean identity?
yes,
Yes.
technically.
No.
Kind
It's
of.
not.
This is cute. That is one.
Right, so it's not a Pythagorean. Pythagorean is x squared plus y squared.
Well, what's stopping you from changing it to X to 4, Y to 4?
Because that's not the Pythagorean identity.
Dang it.
Right, that's not the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared, it's squared. It's not to the 4. But, this is factorable. This is a difference of squares. So we're going to factor this one to secant squared theta plus tangent squared theta
Parentheses.
and secant squared theta minus tangent squared theta. It's
Well, then
factorable.
you have another difference of squares there.
Okay, but now it is squared. So now we can go use our Pythagorean identity. What is the Pythagorean identity with secant and tangent?
One.
What is the Pythagorean identity? What is it?
1 plus tangent squared theta equals secant squared theta. Am I right?
I don't know. That one I
I
don't have memorized. Who has it?
tried to memorize it. I did. Was I right
That's
though?
tangent.
Was that right?
I didn't listen to it.
I said 1 plus tangent squared theta equals secant squared theta. Or 2 did I?
Okay, so if I change this and I move the tangent squared over, then I have 1 equals secant squared theta minus tangent squared theta. So the secant squared theta minus tangent squared theta, that's 1. So if I multiply 1 times this, I now have secant squared theta plus tangent squared theta.
What do we do with that? Change it into sine squared over cosine squared.
So
1
secant,
over cosine
well, we
squared.
could. I mean, we could do something like secant is 1 plus tangent squared theta. And I haven't showed you this yet, but if you add, but we can kind of figure it out. If we add together a tangent squared theta plus another tangent squared theta, then it's 1 plus 2 tangent squared theta. This one really doesn't simplify very much. Like, this is what I have as the answer. You could have this as the answer. You could change this to 1 over cosine squared theta plus sine squared theta over cosine squared theta. Then add those together and get 1 plus sine squared theta over cosine squared theta. And then that doesn't have an identity, so we could do 1 plus sine, I'm running out of space here, sine theta over 1 minus sine squared theta. At least they're all sines, but there's really not any other way of simplifying that one further. So not all things that you're given simplify nicely down to 1, but most of them do. Okay. All right, so the assignment is to finish this worksheet, but I'm going to tell you right now, there are a few challenging ones on them. And I'm going to ask you to kind of separate yourself. If you are going to pre-calc next year, you should be attempting to get the questions that I'm writing up on the board. If you are not going to pre-calc next year, maybe try them and see if you can do it, like challenge yourself, but don't stress over it in sport. You should finish the worksheet with, and then the challenging ones. Hold on. The challenging ones are numbers 11, 17, 18, and 20. So those are the challenging ones. But if you're going to pre-calc next year, you should definitely give it a good effort. All right, because like if you're going to pre-calc, you're going to be expected to be able to do this kind of math. And if you have any questions, I have all the answers, and we can, work together. But when you ask for help, you can't sit there and say, I don't do it. What you're going to need to do is try something, and then come over and say, I got stuck here, or am I doing this the right way? You can't put nothing on your paper and say, I don't know what to do, because I have no idea what's going on in your head. You got to put something down. And then some of you write bigger. You might need paper for the rest of this, because I had trouble squeezing some of it in.